Hello grade 8 learners, my name is Tuto Masudubele and today we will be revising algebraic expressions. Let us revise collecting like terms grade 8 learners. Now what are like terms? Like terms are terms that have the same variables with the same exponents. Same variables with the same exponents. Now if we study the expression that is given on the screen and we count the number of terms, you will realize that we have 4 terms. Why do we have 4 terms? Because terms are separated by a plus or a minus. Now let us collect all the like terms. If you look at the first term, it's 20a squared b. Now I need to look for any other term that has a squared b. Now if we study all the other terms in the expression, and which other term has a squared b, and that will be negative 9a squared b. So it simply means that we need to collect the two and group them together. Now let's look at the second term. The second term is 3ab squared. Now it simply means when we look at the expression, we need to collect any other term that has ab squared. Now what is that other term? And that will be 4ab squared. So simply means in the next statement we have collected those like terms together. Now realize that we have 20a squared b minus 9a squared b plus 3ab squared plus 4ab squared, because we have simply grouped the like terms together. And once we have grouped the like terms together, simply means that we can then add our like terms. So 20a squared b minus 9a squared b will give us what? That will give us 11a squared b. And 3ab squared plus 4ab squared, and that will give us what? 7ab squared. So when we add the like terms together, that is what we have. Now can we continue and add the remaining two terms? And the answer will be no, we cannot add the remaining terms. Why can we not add them? Because both terms are not like terms. Remember, what are like terms? Terms that have the same variables that contain the same exponents. Now let us continue collecting like terms, grade 8 learners. Now let's study the expression that is given on the screen. The first term is negative 12x squared y. So which other term in the expression contains x squared y? And that will be 7yx squared. But notice the order in which the factors are written. The order is not correct. Why is it not correct? Because we always write our expressions in alphabetical order as well as in descending powers of the variable that we're working with. So the two are like terms, negative 12x squared y and 7yx squared. So they need to be grouped together. Which other term will contain p and q? And that will be negative 8pq. So it simply means we then have to combine or to collect 6pq and negative 8pq in the next statement. So indicated here on the screen, realize that the second term is now written as 7x squared y, because what has happened is that we have rearranged the factors so that they're in alphabetical order as well as in descending powers of the variable that we're working with. So we have now collected the like terms together. Once we've collected the like terms, simply means that we can then add those two like terms. So if you add the like terms, negative 12x squared y plus 7x squared y will give us negative 5x squared y, and 6pq minus 8pq will give us negative 2pq. And that is what we have in our next statement. Now, can we add the two terms? No, we cannot add the remaining two terms because they are not like terms. And what are like terms? Terms that contain the same variables that have the same exponents. Before we continue simplifying algebraic expressions, grade 8 learners, it's important that we understand the order of operations. We call this the golden rule of mathematics. And what is that order of operations? The acronym is called BODMAS. Now, first on the priority list is that if you have an expression that contains brackets, please make sure that you evaluate the expression that's within the bracket first. And then second on the priority list, you have your orders. What are your orders? Those are your exponents and your roots. So expressions that contain exponents and roots, make sure you evaluate them second on the priority list. And then thirdly, we have our division and multiplication. So third on the priority list, division and multiplication. And those expressions will be evaluated from left to right. And then last on the priority list is addition and subtraction, and that will be evaluated again from left to right. So always remember your order of operations, BODMAS. We call it the golden rule of mathematics. Now that we have revised the order of operations, grade 8 learners, now let us simplify the expression that is given on the screen. Now, because of the order of operations, where do we need to start first? Remember, multiplication is higher on the priority list compared to addition and subtraction. So we first have to multiply the factors first according to the golden rule of mathematics called BODMAS. So if we multiply, we'll have 2 times x will give us 2x, and 3x times 6 will give us 18x. So in the next statement is that we have to first multiply our expressions before we can add or subtract according to the BODMAS rule. Now that we've multiplied, what's left in the statement that's given on the screen is simply addition and subtraction. And how do we evaluate terms that contain addition and subtraction? We evaluate them from left to right. But before we evaluate this, remember we spoke about collecting of like terms, and we do have like terms in the expression that's given here. Like terms are terms with the same variables that contain the same exponents. So which other term will contain a factor of x? And that will be 18x. So we first need to collect the two like terms before we can add or subtract. And the other like term, 5 will be -4 because both are constants. So in the next statement, we have simply collected the like terms first before we could add or subtract, and then after we can add our like terms. So 2x plus 18x will give us 20x, and 5 minus 4 will give us +1. Now let's simplify the next expression. So if you realize we have a fraction, in the numerator we have 2 terms, we call that a binomial. In the denominator we only have 1 term, we call that a monomial. Now how do we simplify the expression? We then need to divide each term in the numerator with the term in the denominator. So we'll then have 12x to the power of 7 divided by 4x to the power of 3 plus 8x to the power of 5 divided by 4x to the power of 3, as indicated in the next statement. Now that we are dividing these two terms, all we need to do is to divide the coefficients, and then with the second factor, realize that we are dividing powers with the same base. If you divide powers with the same base, what we do is that you keep the base and you subtract the exponents. So 12 divided by 4 will give us 3. X to the power of 7 divided by x to the power of 3. You keep the base, which is x, and you subtract the exponent. So 7 minus 3 plus 8 divided by 4 will give us 2. X to the power of 5 divided by x to the power of 3. You keep that base and you subtract the exponent. So 5 minus 3 will give us what? 2. So that is what we have in the next statement. And then all we need to do is to simplify the terms in the exponent. So if you simplify that, we'll have 3x to the power of 4 plus 2x squared. Can we add the remaining two terms? No, we cannot add them because the two are not like terms. Simplify the next expression. The next expression requires us to use the distributive law. The distributive law tells us that you multiply the factor that's outside of the bracket with each term that's inside the bracket. Multiply the factor that's outside of the bracket with each term that's inside the bracket. So if you evaluate the first term, 2x cubed multiplied by x squared will give us 2x to the power of 5. How did you get x to the power of 5? If you multiply powers with the same base, you keep your base and you add the exponents. And then 2x cubed multiplied by -3 will give us -6x cubed. We then evaluate the second term. 4x cubed multiplied by 3x squared will give us 12x to the power of 5. When multiplying powers with the same base, you keep the base and you add exponents. And then 4x cubed multiplied by -6 will give us -24x cubed. We then have to collect our like terms since we are adding terms here. So how do we collect like terms? We look for terms that have the same variables with the same exponents. The first term is 2x to the power of 5. Which other term contains x to the power of 5 in the expression? And that will be 12x to the power of 5. So the two need to be grouped together. The second term is -6x cubed. Which other term has x cubed in the expression? And that will be -24x cubed. So we need to combine the two together. Now that we've combined our like terms together, we then need to add the like terms. So if we add the like terms, we'll then have 14x to the power of 5 minus 30x cubed. Now the two terms that are left are not like terms. That is why we cannot then add or subtract the two terms from each other. Now let us simplify an expression that contains roots. Now the first term contains a cube root, the second term contains a square root. In order for us to simplify the expression, we need to express our bases in exponential form. 27 can be given as 3 cubed, 16 can be given as 4 squared. We then need to divide the exponent of each base with the root. We need to divide the exponent of each base with the root. Now in the second term, because we're given a square root, it means we have an invincible 2 that's normally not written with the root. So in the next statement, we divide the exponent of each base with the root. So we have 3 to the power of 3 divided by 3 times a to the power of 24 divided by 3 plus 4 to the power of 2 divided by 2 times a to the power of 16 divided by 2. We then simplify our exponents, and that will give us 3a to the power of 8 plus 4a to the power of 8, and we check whether can we add the two terms. Yes, we can, because they are like terms. So the like terms with the same variables that contain the same exponents. So if you add the two, we'll then have 7a to the power of 8. Now let us study the expression that is given on the screen. If you are asked how many terms are there in the expression, you count the number of terms, and remember terms are separated by a plus or minus. So you have 1, 2, 3, 4. We have 4 terms in the expression. What is the coefficient of b? We look for factors that are being multiplied with b, and b is contained in the second term. And which other factors are being multiplied with b? And that's negative 2 as well as c. So the coefficient of b will be negative 2c. What is the constant term in the expression? We look for any other term in the expression that does not contain any variables. And that any other term that does not contain a variable is negative 8. And negative 8 will then be our constant term. That brings us to the end of my lesson. Please scan the QR code to access the quiz on algebraic expressions. Or alternatively, you can access the quiz through the link displayed on the screen. And I would like to wish you all the best. Keep on practicing mathematics. Good luck, grade 8 learners.